Hey Algebra 1, I just want to make a video to go over the review for tomorrow's test. If you go through this video, I'm not going to go through every single problem in the review because we went over some of them in class already, so I'm going to basically go over the ones we didn't go over. And I might go over some of the ones that I feel like are important. Okay, so let's go ahead and get started. If you can't understand everything, I just want you to at least watch the important parts of the video, okay? Now, we did this in class, we did this in class, we already did this in class, we did this in class, we also did this one in class, and remember, don't do this one, and I believe we did that one in class. But we didn't do this one, we didn't do this one, we didn't do this one, we didn't do this one. So I'm going to go through these ones with you guys, okay? I'm going to go over a couple. So first let's look at the one for substitution. Now the reason on this one, we need to decide, do we use substitution, or do we use graphing, or do we use equal values, or do you use elimination, or elimination with multiplication, where we have to change it. So we have to figure out which one is the best. Now in class, we said, oh, well, this one's substitution. Substitution is the best, the easiest, because I have a y by itself, a letter by itself. So if that's the case, now I take this x plus 2, and I plug it in for the y. And then let's solve the rest. So now, let's zoom up here. So now I have 3x plus 5, and anytime we plug in, we write parentheses x plus 2 equals 10. Okay? Now, we do nothing with the 3x, but now we have this 5 times x plus 2. So we distribute, we multiply. And then 5 times x is x, 5x, and 5 times 2 is 10, equal to 10. Now, combine the terms that are like each other. Which ones are the same? The 10? The 5? No. They both do not have x. The 3, the 5, yes, they have x. So yes, add them. So 3 plus 5x, 3x plus 5x is 8x. Then we still have 10 equals 10. Now I want numbers to the left, and I want, x's or letters to the left, variables, and I want numbers to the right. So here, subtract 10. This way 10 goes away. And now I have 8x equals 10 minus 10, which is 0. And some say, oh, well, no solution, right? No. It's no solution if we have no more letters. We have no more letters, and the numbers are not equal, no solution. But we do still have letters, so we keep going. So now here, our last step would be just like any other problem. Divide by that number, 8. This cancels out. And now x is equal to 0 over 8, which is just 0. But that's not my solution. My solution is x and y. So take the easy equation, which is y equals x plus 2, and plug it in. Now 0 plus 2 is just 2. Y equals 2. Now my solution is 0, 2. Okay? Now the next one. Now we already did B in class, so I'm going to look at C. So now C, I have to change the equations so that I can get opposites Same number, but one is negative and the other is positive, right? One has to be negative, the other has to be positive. So what's the best to choose, x or the y? I choose the x. And do I change one equation or both equations? I change one. Okay, I'm just going to change the bottom. So I'm going to change these x's so that I can make the opposite of 4x, which is negative 4x. So what do I multiply times 2x to make it negative 4x? Negative 2. So now make your new equation by multiplying the negative 2 to all the numbers. Negative 2 times 2x is negative 4x. Negative 2 times 3y, positive 3y. Negative 2 times 10, negative 20. That equation goes away. And then bring down the other equation, because it's much neater and easier. Okay? So now we add the equations. So now negative 4x plus 4x goes away. Eliminates. That's what we want. Opposites eliminate. 6y plus 2y is 8y. And then negative 20 plus positive 20 eliminates. And some of you go, oh wait, no solution, no solution. Or real numbers, all real numbers. No, because we still have a letter. If we still have a letter, we will have a solution. Okay? So now that is just 0. And do the same just like the last one. Divide by 8 on both. Goes away. And y is equal to 0. And then pick an equation and plug in the 0. I'm going to pick the second one. The numbers are smaller. The numbers are smaller, so I think it's easier. So I plug in the 0. When I plug in, I write parentheses. Now 2x, 3 times 0 is just 0. So now it's going to be minus 0 equals 10. And then the 2x minus 0, well, the 0 just goes away. And our last step is divide. When we have one number on the left and one number on the right, we divide by 2. So now x is equal to 5, 10 divided by 2. But that's not my answer, that's not my solution. That just tells me what is x and what is y. My solution, my answer, final answer, is in parentheses. What goes first? X and then y. X is 5, y is 0. That's the answer. Okay? Now the next one, I'm going to go a little faster. Now this, they're both y equals. If they're both y equals, well then let's do this the easy way. Let's set them equal and do equal values. Okay, let me show you what that looks like. Equal values method. Equal values method. Okay, that's what I'm going to do now. They're both y equals, so I can make them equal. So now take the first equation, negative 2x minus 3, equals the other equation, x plus 3. Now solve. Make my line. I want x's on the left, numbers on the right, so add 3 here, because it's negative. Goes away, add 3. So now I have negative 2x here equals x. 3 plus 3 is plus x. Now, again, x is on the left, numbers on the right. X has to leave this side, so minus x. This x goes away. Now, the new equation will be negative 2x minus x. This is also a 1, so negative 2 minus 1, negative 3x equals 6. Last step, divide by 3. No, negative 3. If this is negative, divide by negative. So now x equals 6 divided by 3 is 2, but there's a negative, so negative 2. And then take that answer, plug it in the equation, and we get y. Plug it in for the x. Y equals, parentheses, negative 2 plus 3. No multiplying, so now just negative 2 plus 3. And y is equal to negative 2 plus 3 is 1. Okay, not my answer though. My solution, x first, x is negative 2, y is 1. Okay, so now let's go down to this problem here. I'm going to skip E and I'm going to go to F. Some saw this equation and some did not. The nice thing is that this one doesn't take too long. So I need to change these equations. I do not have opposites. I have different signs, negative on top, positive on bottom, but I don't have the same number. Now the ones on the top are smaller. Can I multiply the top times the number so that they will be opposites of the bottom? Yes. 2. Let's multiply 2 to all of them, all the numbers. So now my new equation, 2 times negative 3x, negative 6x. 2 times negative 4y, negative 8y. 2 times 6, positive 12. That equation goes away. Now, add the two equations. 6x minus or plus minus 6x is 0. Then 8y plus negative 8y goes away. They're opposites, so they go away. So now I have 0 over here. And then negative 18 plus 12 is negative 6. Are these equal? No. If they're not equal, no solution. Or undefined. Or no answer. Okay? Those are all okay answers. Okay, now let's go down here. Now I'm going to take a look at this one, and this one, and this one. Okay, so now this one, it says determine. Determine means like find it if the given value is a solution to the equation or the inequality. Is this number here, these numbers here, are these numbers here, or are these numbers here, are they answers? Are they correct? So to find that, we need to take their answer and plug it into the x. So if this is x equals negative 11, plug it into the x. So now I have 3 parentheses times negative 11 minus 8 equals 4 parentheses times negative 11 plus 1. Negative 11 times 3 is negative 33 minus 8. 4 times negative 11 is negative 44 plus 1. And use a calculator. Use your Hasiba, calculadora. Necesita una calculadora? Then use it. Okay? Use the calculator. Don't be afraid of it. It's okay. Now, negative 33 minus 8 is negative 41. Negative 44 plus 1 is negative 43. Are they equal? ¿Es igual? No, it's not equal. So this is a no. X equals negative 11 is not the answer. Not correct. Okay, so now let's look at this one. Oh wait, we weren't going to do that one. We're going to do C. Okay, so now for C. This is the solution. There's two numbers. Two letters, two numbers. What's the first number? X. What's the second number? Y. So, if the first number is X, I plug it in for X. The second number is Y, I plug it in for Y. Okay? So that one's going to go there, and Y is going to go there. So now I have negative 1 over 6 times negative 6 plus 2 parentheses times 1 equals 8. Now, right here, I have a fraction. I'm multiplying a fraction. You multiply a fraction, then make the other number a fraction. Let's actually do that in a different color. Make the other number a fraction. Now multiply across. Multiply here and multiply here. Now if I have a negative, make the 1 a negative. So it's negative 1 times negative 6. Positive 6. Then 6 times, actually let's not even worry about the negative. Let's just do 1 times 6 is 6, and 6 times 1 is also 6. And then I have a negative times a negative, so it would be a positive. Now it's plus 2 times 1 is 2 equals 8. And then 6 divided by 6 is 1. Plus 2 equals 8. 1 plus 2 is 3 equals 8. Are they equal? No. So this is incorrect. Negative 6 and 1 is incorrect, not correct. Because this is not equal. It's not true. No es verdad. Okay, now this one. Now this one, we're going to do the same. Take your X, plug it in. Take your Y, plug it in. So now I have negative 1 here, less than, minus, oh sorry, parentheses. Now I have a negative here. Pay attention, negative X. So negative, parentheses, negative 2. Plus 6. So negative 6 less than or equal to, if I have a negative and a negative times a negative, I have a positive. So now positive 2 plus 6. Then negative 1 less than or equal to 2 plus 6, 8. Is negative 1 less than 8? Or is it equal to 8? Yes, it is. So this is correct. It's good. Okay, now this one. I'll quickly do this one. So if I have X is less than or equal to equal to 3, the boundary point. Boundary point is 3. And is it included in the solution? Is it a part of the solution? Yes, it is included. It is a part because I have an equal. If it's equal, 3 is a part of the solution. So yes, it is a part of the solution. Okay? Now, we have to graph it. So remember, if I have an equal to sign, if it's less than or equal to, do I make an open dot or do I make a closed dot? I make it closed, and I do it right at 3. And do I shade to the left or do I shade to the right? It's less than, so that means it's more negative. X is less than, so we shade to the left. Okay? Now it says, write the solution as an inequality statement. All you need to do is write x is less than 3, you're equal to 3. That is your statement. That is the statement. Okay? Now it says name 2 possible solutions to the inequality. 2 possible solutions. A possible solution is anywhere that's in the shade. Anywhere that's in that shade. So a possible solution could be x equals -8, or x could equal -5. So x could be one of those numbers. It could be any of them. Okay, number 8. Solve the inequalities. Solve the inequalities and graph them on the number line. Make sure that you test a point to see if it's correct. Okay, so I need to solve it, graph it, and test it. So now, let's go to A. I need to get x by itself. So I'm going to solve it kind of like an equation. I need x by itself, so -5 has to go. Add 5 to both sides. 5 goes away. Then I have 4x is less than -21 plus 5, which is -16. Then last step, divide by 4 to get x alone. Then x is less than -16. 16 divided by 4 is 4, and it's a negative divided by a positive, so it's negative. So there's my inequality. X is less than -4. So now we graph it. Now it's less than, so it's open at -4, and it's less, so that means I shade to the left. Now I need to pick a point to test. So let's pick -8. So plug in -8 to the inequality. -8 less than -4. Is that correct? Yes, it is. So we're good. I did it correctly. So now the next one, B. This one's a little different. So now here, draw your line. I want x by itself, so again, make the 4 go away, and it's positive, so that means I'm going to minus or subtract 4 from both sides. Then I have -3x here, less than or equal to 25 minus 4, it's 21. And then I need to divide by the -3, and this goes away, and I have x here, and 21 divided by 3 is 7. And it's positive divided by negative, which is negative. And if I divide by a negative, that makes the sign switch. So it's not less than or equal to now. It's going to be greater than or equal to. If I divide by a negative, it switches. So now I'm at -7, and it's a closed dot because it's equal to, and x is greater than, so a shade to the right in the positive because it's greater than all the way across. Now I need to pick a point to test. So I'm going to pick -2 to test. Plug in -2. Is -2 greater than or equal to -7? Yes. So we're good. I am correct. Okay, now write the inequality that represents, this number 9 says write the inequality that represents all real numbers greater than or equal to 8. Okay, if you see all real numbers is just x. Now if it says greater than or equal to, that's a greater than or equal to sign. and then it says greater than or equal to 8. So it's just 8. So that's all you write. Now this one, it says, is the point 4, 5, is it a solution for this equation and this inequality? We need to figure out, is that a solution? So, and we're going to do it by graphing. Now we could plug that in. We could plug in the 4 and plug in the 5 and figure out if it's true and if it's a yes or a no, and that would tell us the answer. But this way we're actually going to graph it instead. So now let's graph this equation. Our starting point, or y-intercept, is positive 3. And our slope is 1 over 2. So we go up or we go down? Up, how many? 1. And to the right, how many? 2. Up 1, right 2. Up 1, right 2. And then go the other way. Down 1, left 2. Down 1, left 2. And then make your line. Now I need to graph the point 4, 5. Graph the point. So x is 4, so here's x, and y is 5. So I find where they meet, and there's my point. Does it touch the line? Yes, it does. So yes, 4, 5 is a solution. It touches because it touches the line. Now this is true if it's equal. If it's an equal. If it touches the line when it's equal, then it's a solution. But what if it's greater than over here? This is the same line. Now remember, when you graph this one, the inequality, if it's less than or greater than, you make a dashed line. If it's less than or equal to and greater than or equal to, you make a solid line. So here would we make a dashed or solid? Dashed. So I'd start at 3 again and do the same. Up 1, right 2, up 1, right 2, up 1, right 2, and then go back the other way, down 1, left 2, down 1, left 2. And now, instead of a solid, I make a dashed line. And now, if I have a greater than or less than sign, I need to shade. Okay, I need to shade it. And this is greater than, so that means I'm going to give, a thumbs up. Thumbs up. Oop, there we go. If it's greater than, thumbs up. If I have less than, then it's thumbs down. Thumbs down. Okay? So now, this is greater than, so thumbs up, so I shade above. So I shade thumbs up, I shade up. So now, 4, and I shade and do the dashed line when I have inequalities, less than or greater than. If it's just equal, like this one, all you do is draw a line. But when you have inequalities, less than or greater than, you need to make a dashed or solid and shade. Now let's graph that point again, 4, 5. Here's 4, x, here's the 5 on the y. Uh-oh, my shading disappeared. There we go. Okay, and there's my point here. And some of you say, oh, it touches the line. But the line is dashed. If the line is dashed, it does not matter if it touches the line. It has to be in the shade. If the line is dashed and it touches the line, it is not a solution. If this line was solid and it touches the line, it would be a solution. But if it's dashed and it touches the line, it is not a solution. So not a solution. Okay? And then That is it, folks. Come see me early in the morning if you need some more help.